Welcome to part 3 of the Digital Dynamics Studio walkthrough tutorial. If you remember from part 2, we set up a model in the modeling tab for our simulation of airflow past a cylinder, which is what we're trying to simulate in these walkthrough tutorials. So if you go to the modeling tab, you can see this is the model that we ended up with at the end of part 2. Airflow is going to be, or wind flow, fluid flow is going to be coming through boundary number 2 on the left, go around the cylinder, which is boundary number 1 here, and leave the domain on the right here in boundary number 4. And the tops and the bottoms, boundary 3, are there to allow the fluid to slip along those boundaries, but not to penetrate those boundaries. So if you haven't reviewed part 2 of the walkthrough tutorial, feel free to go back and watch that video and see how we got to this point. So in this tutorial, we're going to continue where we left off and load that model in the simulation tab and get it ready for performing the actual simulation. We'll actually do the simulation in part 4, the next part of the walkthrough tutorial, but for now we're just going to load it and set everything up to get ready for that simulation. So this is the first time you're going to the simulation tab. This is what you're going to see. Nothing is loaded, nothing is set up for a simulation, so it's all blank, but similar to the modeling tab, which we talked about last time, most of the space in the browser is your simulation workspace. You'll see the meshes and simulation results and the animations in this window once we have something loaded and simulated. But for right now, since nothing is loaded, everything's blank and most of the controls are disabled because you can't do anything until something is loaded. But here at the top, we have a few commands. We'll talk about those in a second. And then the bottom are basically our simulation controls. Again, they're disabled because we haven't loaded anything yet, and there's nothing to simulate yet, so they're all disabled, but we can quickly cover what they do. These two icons on the right are our simulation run controls. The little person here is standing, which means nothing is, that's what you would push to start your simulation. Then you can see like the modeling tools. If you hover over any of these items, a pop-up appears kind of showing you what they do. So it's always a quick way to see what happens if you were to push those buttons. But the two buttons on the right are your simulation run controls to start and pause the simulation, and the other button is used to reset the simulation back to the beginning. The other set of controls here on the left are your simulation playback controls. Once you've ran your simulation, you have some frames actually computed and cached internally. You can play those back at a faster rate at any time. That's controlled here on the left. So they're very similar to any kind of media playback controls. You can play back the simulation, step forward, step back, jump to the end, jump to the beginning. And this movie button here on the left will allow you to record your simulation for download as an MPEG movie that you can share with others. And we're going to talk about that in part 6 of the tutorial, so we'll talk about more of that later. And this line here at the bottom, that's your simulation timeline. Once you have a simulation loaded and running, it'll show you how far the simulation is, how many frames have been computed so far, which frame you're actually seeing on the screen. But we'll see that in the next part 4 of the tutorial when we actually run a simulation, but that's the actual timeline. So here on the top, we have a few commands. Load. This is where you start any new simulation. When you push this button as a menu, and all your saved models are shown, you can load those for a simulation if you wanted to. And then there's this option up here, current model. We're actually going to push that button. We'll talk about that in a moment. But this is where you start a new simulation. You load a model to get it ready for simulation. And these other buttons here bring up other displays, parameters. That's your simulation parameters. And that sets what simulation type you're going to do, simulation values, time step size, viscosity, and a few boundary conditions are set here. A few other things. We'll talk about that in a moment, but these are your simulation parameters. And this is display. These are your simulation display parameters. This shows what is shown on the screen. There's a bunch of fluid variables, pressure, velocity, particle trace visualizations, all kinds of different things. We'll talk about that and more in the following walkthrough tutorials, but this is where you control what you're seeing on the screen. And there's a couple other panels that also it controls, and we'll talk about those in the following tutorial. But this is all your simulation display controls are here under display, and you can pop those up and close them at any time just by toggling those buttons. So let's get things set up to run our simulation of airflow past the cylinder. So the first thing we need to do is load our model. So we go to load. These are save models. I have 2 save models right now. We're not going to load those. We could, but we're not going to do that now. We're going to load our current model. If you remember, there's always a model in the modeling tab. There's always something there. Either it's the default model or the model that you're currently working on. This is the model that we want to simulate. It's already in the modeling tab. So when we go to simulation load, we can just choose current model and load that model and get it ready for simulation. So when I do that, when I push that button, it's going to load that model and get it and bring it into the simulation tab for simulation. You can see that has happened. There's our model. There's the cylinder. There's the inflow boundary. All the side boundaries are there. So actually what happened when we pushed that load button, it loaded the model and it created the initial unstructured mesh to be used for the simulation, which is what you see here on the screen. So basically fills in the area of your model with, divides it up into a bunch of triangles. This is your mesh, an unstructured mesh. And that's kind of the backbone of the simulation. The triangles themselves are called elements, and the node at the corners of the triangles are called nodes. When you run the simulation, it's going to solve for fluid flow variables, velocity, pressure, maybe some other variables at each of the nodes of the mesh. And then it's going to interpolate those values in between within the triangles. That's how numerical methods work. But this is the initial mesh. As you'll see in part 4, when we run the simulation, the mesh is fully dynamic. It's going to change its structure. It's going to change its shape. The elements are going to be created. Nodes are going to be created and destroyed. Basically, it's going to adapt itself to follow what's happening with the result, with the fluid flow, which is going to develop behind the cylinder. So it's a fully adaptive method, and this is just the initial mesh. As you see in part 4, it'll change its structure, it'll change its shape throughout the entire simulation. But this is what gets us going in the simulation. This is the initial mesh. So in the next thing we want to do is set up our simulation parameters. So we always should review our simulation parameters. Actually, as you can see here, the man icon here on the bottom right is standing, which means he's ready to run. If you push that button, it would run the simulation. We're not going to do that right now, but and then the icon would change into the running state. But the person icon here is currently waiting for the simulation to be began. We're not going to do that right now, but before you do that, you should always review your simulation parameters up here. So we should open the parameters tab and review the information within. So the first thing you want to verify is the simulation type. There's a couple available. Most of the time, we're just going to do straight incompressible flow. The documentation, of course, talks more about these things, these simulation types. But incompressible flow is just the basic simulation type that we're going to do. The time step sizes here. When we do the simulation, it's kind of like a movie. You're going to calculate the results at distinct intervals in time. And set those intervals are separated by a time step size. These aren't seconds or anything. If you model it that way and set up all the parameters, maybe it really means seconds, but it's really simulation time. So 0.01 in simulation time, we're going to calculate the solution at that interval throughout the entire simulation. For this simulation setup, 0.1 is just fine. That's fine for this kind of simulation type, but that's one of the variables you might want to play around with when you're running a simulation. The next thing is viscosity of the fluid. Basically, the results we're going to get in these incompressible flow simulations are governed by the Reynolds number. And Reynolds number is a non-dimensional parameter. It's basically inflow velocity times the diameter of the object, the cylinder in this case, divided by viscosity. So we modeled this cylinder. We know that its diameter is 2.0. If you remember from the previous walkthrough tutorial, the inflow velocity, you'll see in a moment, is going to be set at 1.0. So you do the math, velocity 1.0 times the diameter of 2 divided by viscosity. That's going to be a Reynolds number of 400. So we're going to do a simulation of airflow past the cylinder at Reynolds number 400. And of course, you could change the viscosity value and do a different Reynolds number or a different viscosity, but right now, 0.005 is good for the simulation you want to do, so we'll just leave it at that value. The next toggle over here is the turbulence modeling toggle. We're not going to talk about that or use that in this simulation. The documentation talks about that, but for very high Reynolds number flows, there's going to be lots of very small features in the flow that the mesh, no mesh, this mesh, not any mesh, could actually capture. So all you can do is model their effect on the flow. So very high Reynolds number flows, you might want to enable the turbulence model, but we're not going to use that or talk about that here. The documentation covers that if for people that are interested in those kinds of options. The next thing we want to review is our boundary conditions. So we can open that up and look at the boundary conditions. Remember, we talk about those in part 1 of the walkthrough tutorial. Boundary 1 is the cylinder itself. We need to associate a boundary condition right here in the middle with each of the boundaries of our model. Remember, we had 4 boundaries in our model. Boundary 1 is the cylinder. There's several options here to choose from. We want no slip. Basically, the flow is going to have a velocity of 0 on the cylinder. 2 is this left inflow boundary, where the fluid is entering the domain, so that's an inflow boundary. For typical setups like this, the default values for these boundary conditions are usually sufficient. You should definitely review them, but in most cases, they're probably correct. So boundary 2 is the inflow boundary, and the velocity of that, the speed of the fluid coming in, is set right here, 1.0. You could change it to something else if you wanted to, but usually 1.0 is what we want it to be. We like to use values that are close to 1 or equal 1.0 exactly. And inflow velocity is one of those things we usually just leave at 1.0. Remember that value was used in the Reynolds number, which is velocity times diameter divided by viscosity. So that's the velocity that we would use in the Reynolds number calculation. 3 is the tops and the bottoms of the domain. And as we said before, X slip is fine with that. Allow the flow to slip along the boundary in the X direction, but not penetrate the boundary. And boundary 4 is the one here on the right, and that gets the ELF flow boundary, where it allows the fluid to cleanly exit the domain through that boundary. Again, usually for a typical setup like this, these are the boundaries we will have, and these are the boundary conditions we want, but you should always review the boundary conditions, and maybe you added a different boundary or a different object in here, and you would have to maybe you added a boundary 5, and you would have to specify a boundary condition type for that boundary. So anyway, those all look good. There's some advanced parameters. We're not going to cover these here. The documentation talks about them, and for most simulations, you probably don't have to deal with these too much. But there are a set of advanced parameters. If you're interested, you can look into those. So that's pretty much it for the simulation parameters. We reviewed them all. The next step would be to go ahead and run the simulation. But before we do that, I want to just demonstrate one other quick thing. As an example, let's say I wanted to change the model. How easy is it to change the model and set up for a new simulation? Well, it's very easy. Remember, there's always your model is loaded in the modeling tab. So at any time, you can go back there and change it. So let's just say for some reason, I want to add a square to the model. So I could do that. Let's put the square over here, put the cylinder back to the center. Let's rotate the square a bit. Let's say for some reason this is what I wanted to simulate. So you just go to the modeling tab, make that change. You can go back to the simulation tab and just reload your current model. And there, now I'm ready to simulate a cylinder with a square behind it, if that's what I wanted to simulate. So it's pretty easy to go back to the model, make a change, and go back to your simulation tab and reload it and do the new simulation. But we don't want that. We just want our cylinder. So let me go back. Let me delete that square, go back, reload the current model, and I'm ready to go. When the model is still the same, it might be modified or changed, but the model itself is still the same. So the simulation parameters haven't changed. When I did that, they should still be the same. You should definitely review them again, but they should not have changed. So at this point, you're ready to do the simulation by pushing the standing person icon here in the bottom right. We're not going to do that right now. That's going to be the topic of the walkthrough tutorial part 4. So go there and follow along with the next steps, and we'll see you there. Thank you.